Hello friends, I Dr. Sonendra Gupta, professor in the Engineering Mathematics Department of Basic Science. In the previous lecture, we have discussed about the definite integral as a limit of sum part 1. Now we have discussed the definite integral as a limit of part 2. Now first of all, we discuss about the basic definition of the definite integral as a limit of sum. We know that if f of x be any bounded and continuous integral function in the closed interval ab, then the integral a to b f of x dx equal to limit h tends to 0 h f of a plus h f of a plus 2 h up to f of a plus n minus 1 h, where h equal to b minus a upon of n, so that nh equal to b minus of a. When we solve the definite integral limit of some question, so we need some important result. Now we have discussed some important results are 1 plus 1 up to m times, so we can say n, 1 plus 2 plus 3 up to n times, so we can set summation n, which is equal to n plus 1 upon of 2. Now third, 1 square 2 square plus 3 square up to n square, which we can say summation of n square, which is equal to n plus 1 2n plus 1 upon of 6. Fourth, 1 cube plus 2 cube plus 3 cube up to of n cube times, it means the summation of n cube, which is equal to n plus 1 upon of 2 whole square. Therefore formula number 5, sin alpha plus beta sin alpha plus 2 beta up to sin alpha plus n minus 1 beta, which is equal to sin alpha plus n minus 2 beta sin n beta by 2 sin beta by 2. And the sixth formula, cos alpha plus beta plus cos alpha plus 2 beta cos alpha plus n minus 1 beta, which is equal to cos alpha plus n minus 1 upon of 2 beta sin n beta by 2 into sin beta by 2. Then a plus ar square up to ar to the power n minus 1, which is equal to ar to the power n minus 1 upon r minus 1, which is r greater than 1, a 1 minus r to the power n 1 minus r when r less than 1. And the eighth formula, limit x tend to 0 sin x upon x equal to 1, limit x tend to 0 cos x equal to 1, and limit x tend to 0 tan x upon x equal to 1. And the ninth formula is limit x tend to 0 e to the power x minus 1 upon of x equal to 1, limit x tend to 0 e to the power x minus 1 upon of x equal to log base e. ये जो हमने फॉर्मूले पढ़े हुए हैं, ये हमारे पास सारे फॉर्मूले हमने आपको बता चुके हैं। इसके अलावा आज हम स्पेशली बात करेंगे क्वेश्चन जो हमारे पास एक्सपोनेंशियल और ट्रिग्नोमेट्री पर बेस्ड है। तो लेक्चर नंबर 1 को देखना ना भूलिए। आवर फर्स्ट क्वेश्चन इज evaluate integral a to b e to the power x dx by definite integral s as limit of sum. Here we see that e to the power x, our function, that means f of x equal to e to the power x, so that nh equal to b minus of a. And we know that by the definite integral limit of sum, we have integral a to b f of x dx equal to limit x tend to 0 f of a plus h f of a plus 2h f of a plus n minus 1 h. Now f of x equal to e to the power x, so that e to the power a, that means here, that means next value e to the power a plus h, and the next value e to the power a plus 2h a plus, or then the last value e to the power a plus n minus 1 h. So we can write in this way, like this much. Now e to the power a is common from the each term, so we can get limit x tend to 0 h 1 plus e to the power h e to the power 2h plus e to the power n minus 1 of h. Now here we see that here this is a geometric series, so we require the value of a, which is the a equal to 1, and the value of r, which is called the common ratio, that means the second term divided by the first term, that means the e to the power h divided by 1, that means which is equal to e to the power of h. Obviously e to the power h is greater than 1, so we can apply the formula of ar to the power n minus 1 upon of r minus 1. Okay, so e to the power a, limit x tend to 0 h 1 e to the power h to the power n minus 1 upon of this much. Now we can separate the term h with e to the power h minus 1, like in this way, and the e to the power nh minus of h upon of this. So now the value of the e to the nh is b minus of a, so we can write in this way, like this much, and this value is equal to the 1, as you know that, because by the property of the limit, and we putting the value of the nh, so we can get e to the power a into e to the power a into 1 into e to the power b minus a minus 1. Now we can multiply e to the power a with the e to the power b minus a, so we can get e to the power b minus e to the power of a. Now this is your required result of integral of e to the power x dx by the definite integral limit of sum. Now we have solved one more question. Evaluate integral a to b cos x dx by the definite integral limit of sum. Here f of x is the cos x and the nh equal to again b minus of a. So we can write nh equal to b minus of a, and we apply the definition of the definite integral limit of sum. So we can say that this f of a is equal to cos a, f of a plus h equal to cos of a plus h, f of a plus 2h equal to cos of a plus 2h, or f of a plus n minus 1 h equal to cos of a plus n minus 1 h. Okay, now here the alpha is a and beta is h. Why? Because if we compare this equation by this formula, we can see that cos alpha, that means alpha is equal to of a, then alpha plus beta, that means h, alpha plus 2 beta, that means beta equal to of h. So we putting the value of alpha equal to a and beta equal to h in this formula. So we can get h cos a plus n minus 1 upon 2 h sin nh upon of 2 sin h by of 2. Now we can multiply the h in this term, so we can get, and we h separate by this term. Okay, now here, now this is sin h by 2 and this is the h, so we can multiply the divide and by 2 in the next term. So we write in this way. Now this value is 1. Okay, now putting the value of nh equal to b minus of a, so we can get in this much. Now again we apply the limit h tend to 0 here, so we can get 2 cos a plus b minus of a sin b minus of a. Now we simplified this term, then with 2 cos b plus a upon of sin b minus of a, and we know that the formula cos c sin c minus cos sin d, which is equal to 2 cos c plus d by 2 or sin c minus d by 2. So we can say sin b minus of sin a. This is your required result. Okay, now again we discuss the third question. Evaluate 0 to pi by 2, 0 से pi by 2 sin x dx by definite integral limit of sum. Here f of x equal to sin x and the nh is pi by 2 minus 0, that means the value of the nh is p minus a, which is the pi by 2 minus of 0, which is equal to the pi by 2. Now by the definition of the definite integral limit of sum, so we can that integral a to b f of x of dx equal to this much. Now putting the value of a here 0. First of all we were putting the value of a equal to 0 in each term, so we can that we can see this much. Now here alpha equal to 0 and beta equal to h. Okay, alpha equal to 0 and beta equal to h, and we know that the formula of the sin alpha plus beta sin alpha plus 2 beta equal to of this much. Okay, so we putting the value of the alpha equal to 0 and beta equal to h, then we get this much. Now we simplified the term. Now we can multiply this term into this term, and this h which can separate by of this much. So we have this 2 sin h by 2 sin h by 2, and sin limit h tend to 0 sin 0 plus nh minus h upon of this. Now this value is 1. Now this value is 1, and the nh value is pi by 2. So we putting the value of the nh pi by 2. Now again apply the limit h tends to 0. So we can get 2 into of this much, that this value is pi by 4. Okay, the 2 into sin pi by 4 into sin pi by 4. Now sin pi by 4 equal to 1 by root 2, and sin pi by 4 equal to 1 by root 2, that means which is equal to of 1. So finally we get the 0 से pi by 2 sin x dx equal to of 1. तो आपको मेरा लेक्चर कैसा लगा है मुझे जरूर बताएं. थैंक यू सो मच.